Let's look at and or in the context of probabilities. If we want to find the probability of A and B, we want to identify outcomes in the sample space that meet all of the criteria listed, both A and B. But if we want to find the probability of A or B, we just have to find outcomes in the sample space that meet any of the criteria listed. I'm going to do a simple example from the tree of rolling a six-sided die one time. It's important to make note of what the actual experiment is and how that could relate to an and an or. So let's do letter A here. Find the probability of 1 and 6. But keep in mind, this is a single roll of a die. And is it possible to get an outcome which is both a 1 and a 6 at the same time? No, that can't happen. So there would be 0 outcomes that are both 1 and 6. And that makes this an impossible event. But what about the probability of a 1 or a 6? Well, that is possible. 1 would qualify, and so would 6. So we have a probability of 2 and 6. 1/3. Find the probability of getting both an even and an odd number. That can't happen. No numbers meet both criteria. But what about the probability of an even or an odd number? Well, in that case, 1 would work because it's odd, 2 would work because it's even, 3 would work because it's odd, and so on. They would all be successes because they meet one of the criteria. It's certain that if you roll the die, you will get either an even or an odd number. What about prime and even? All right, for that one, I'm going to list the primes and the evens. And let's see if we have any overlap. So technically 1 is neither prime nor composite, but 2 is prime, so is 3, and so is 5. And the even numbers are 2, 4, and 6. Do any of the outcomes meet all the criteria listed? Yes. 2 does. It's the only outcome, though, that meets all the criteria. So let's make our probability 1 and 6. Okay, now let's find the probability of prime or even. Well, 2 would certainly work because it's both. 3 would work because it's prime. 4 would work because it's even. And so would 5, and so would 6. They would all work. The only outcome that doesn't work is 1. It's not prime, and it's not even either. So this gives us a 5 and 6 probability.